Okay, everybody, welcome to COMP2300 week 7. Really great to be back with you guys on the streaming lectures for this week. I definitely know that we have a few viewers tuning in, even though it's early on Tuesday morning. Now it's definitely starting to get a little bit chilly in Canberra, so the cold mornings can be a bit more troublesome to get to. But I think that the content today is going to be pretty interesting, so hopefully more people tune in or they want to catch up with it later, which is fine as well. So today we've got a new topic. We're working on data structures as our topic for this week. That means we're going to be talking all about how you store different kinds of data on your disco board in different structured ways that will make sense to you as a programmer. So I suppose in the course so far, we've been focused on what you're doing as a programmer to create an algorithm. So how your control flow works, how you can do loops, how you can do if-then else's, how you can write functions, and even how you can write something like a macro, which certainly has some, I know I'm enormous, it certainly has some uses, but the difference so far is that we really haven't been dealing with very much data. And of course your algorithms are not very much use until you have a way of storing data and putting it in the right place. So I'm just going to make myself small. Someone's already commented that I'm enormous, which is the way I like to be at the start of the lecture so that you all know what we're talking about. Go down to my, oh, I might just move myself in a little bit. That's better. So now before we get into the content, I think I just want to talk about a few administrative topics. We're going to talk about the assignment, which has just gone in, and the assignment which has now just been released. So first of all, assignment 1 is a wrap now. The grades are in. Your feedback is back. I hope everyone has looked at their feedback and understands what your tutor has explained to you. So I guess, you know, there's been a lot of emails, excuse me, a lot of action on the piazza over the last few hours about grades for assignment 1. And what I'm here to tell you is that I know that it's very difficult, but especially for the first assignment in a course, you need to look at the feedback first of all and the grade second. So the first assignment for a course sometimes sets the standard for what we expect of you as students. And sometimes it's difficult to communicate that standard, even with our best intentions, until we have a piece of work that we can evaluate. So this kind of brings me to one certain important point. Someone's just asked where are the grades and feedback. So far the grades and feedback have just gone out through GitLab, so you'll be able to look into your assignment repo and you'll see a feedback file. There's instructions for that on the Piazza. When we're looking at assessments, sometimes people put assessments for education into 2 categories. One is called formative and one is called summative. So the idea of formative assessment is that it's assessment where we're basically mainly concerned about giving you feedback for how you're going and in sort of a guide to how to improve your work. And I hope that everyone in COMP2300 intends to improve their work over the course. This is not a course where I want you to stay static. The other kind of assessment, summative assessment, is about looking at the work that you've done and sort of saying, well, what's the standard of this? And pushing you out the door of the course with this evaluation in hand. So when we get to the end of a course, and you get to see the grade that you've received as a total of all of the assessment items you've done, that's kind of the final piece of summative assessment. You can't do anything about that now. That's the outcome of this course. Of course, you can hopefully have learned some lessons and use it in other courses, but that's the outcome of the course. And it's similar to, in a similar way we do the final exam. Once you get the final exam grade, well, you can't use that grade or feedback from the final exam to improve any other assessment items because it's the last one. But every other assessment item in this course, you have further chances to do better next time or improve your grade by looking at your feedback in detail and trying to react to what we're telling you in terms of what you've been doing. And that particularly applies to the first assignment, and it will particularly apply to the mid-semester exam as well, because those are two of our first assessments that set the expected standard. Now, assignment 1 was pretty tough, I think. It's tough on new students because it's the first assignment of this course, and you're really only just starting to get the hang of how to do any kind of programming in assembly language. That's the first reason it's tough. The second reason it's tough is that for half of this assignment, part 2, we ask you to write a program that does something cool, and you have to put a lot of effort into that. And then we say, okay, great, you've done your program, now please write a document that explains what you've done in 2 pages and send it to us, and we're just going to assess you on the document. Now, sometimes that can feel a little bit obtuse, because you might say, well, I've already written the code, why can't you just examine me on that? But really, we're examining you on not only the code that you've written, but your understanding of what you've done and your ability to articulate the plan you had, what you did, how you did it in assembly programming, and why the approach you've taken is interesting or might have been better than another approach, or why you made certain design decisions during your process of creating your part 2. And of course, we're also interested in the interesting code you write for part 2. And we do check that it actually works, and if you've done something cool, it's really satisfying for us to see the creative things you come up with. But the design document for part 2 does present some difficulties, and often we get feedback from students that they didn't know what to do, or they have created a design document that really is talking about the wrong stuff. It's not explaining what they've done, how they did it, and why. It's going off on a tangent and talking about different kinds of material. And when it's a 2-page design document, you really have to be very efficient about the information that you're giving us so that we can evaluate it properly. Of course, if someone sends us a longer than 2-page design document, we only mark the first 2 pages. That's how that works. Now, just looking at the marks for assignment 1, I've got these on the screen now. I'm just going to make them really big so everyone can see. The total mean for assignment 1 was 58 marks out of 100. And if I'm honest, that's a little bit low. I'm not very happy about that. The mean for part 1 was 36 out of 50, and that's fine. I think that's a good mean. Of course, this is a very large course. We have a lot of students at different stages in their journey, and a lot of students who are looking at different levels of attainment. There's many students we have who really want to shoot for the top and are willing to put in loads and loads of extra time to get everything perfect. And there's a lot of students who say, I just want to get through this, and that's fine too. For part 2, the mean was 22 marks out of 50, which I think was pretty low, and I'd prefer to see that coming up a little bit higher. And I think this is partly to do with the difficulties that some students have had in writing a part 2, which convinces us that you know what you're talking about and convinces us to give you marks. Now, I'll just talk about some good news, which is when I look down here, this is a typical kind of descriptive statistics output from Python's pandas data analysis library. So we get the mean, the standard deviation. I'm not so interested in that, but I really like looking here at this section, which is the min, max, and the median. The median is if you took all the marks of everyone in COMP2300 together, and we went down the row and found the person in the middle of that row, the mark that they got is the median. So that means that 50% of people had a mark above that, and 50% had a mark below that. And then we've also got these upper and lower quartiles, which is the same process, except it's kind of the median of the median, between the median and the top, and between the median and the bottom. So we're dividing the group into 4 and seeing which marks they got. The great news here is that there's a quarter of this class who got a grade which is more than 75 or more. And that's just wonderful. That shows that there's a really quite a large group of you who are aiming to do really well in these assignments and putting in the effort. It is hard to get an HD in these assignments. These assignments are not easy. So if you're tracking at if you're getting an HD in this assignment, that means you've done a great job. If you're getting between 75 and 80 for these assignments, that also means you're doing a great job. You're in the distinction levels. And I really hope that those who are getting between 75 and 80 can take on their feedback a little bit, and maybe in the second and third assignments, you can do some targeted upgrades of your approach, and maybe you can get into the HD band as well. And that would be wonderful to see. I really encourage you to try for that. The other bit of good news is that half of everybody in the course is getting a credit and above in this assignment. And that's really great too. A credit is a great mark, and that shows that it's literally a credit to you. It shows that you're understanding the course material well, you're tracking well, you're telling us what we need to know. And of course, there's places that you can improve, and hopefully you too can take that information on board and try to push up to the next level as well. Now we get to the not so great news, which is that there's 25% of the class who have a grade which is less than 45 out of 100. And that means that there's a significant proportion of this class right now who are not doing work that we consider acceptable in this class. It's not acceptable to get less than 45. Now, of course, I know that things happen. Sometimes assessments don't go well. Of course, this has been a very difficult time over the last 6 weeks, but the answer to that, unfortunately, is not for us to change our standards and let work that we would consider to be unacceptable to get through our marking process. It's just not going to work like that. So I hope that if you're in that group who got a mark below 45 out of 100, you can look at your feedback and see something there that makes sense to you and think, okay, this is what I was going for here. I can see now that that wasn't working. And for assignment 2 and 3, I'm going to change my approach and definitely get past the bar to pass. And that's absolutely what I expect you to do, and it's absolutely what I think you can do. It's I don't believe that anyone is stuck in that area. Sometimes a few targeted changes in how you approach your design document and how you approach your code quality for part 1 can make all the difference in making sure that you get into the pass band for this course. So just having a look at the grades for the 2 parts, I've got some nice distribution plots. This is the distribution for part 1 of the assignment. So you can see that the most common grade to get was somewhere between 40 and 45 for part 1, which is great. That shows that people are basically following the instructions, getting the specifications of their part 1s right, getting the code in, and submitting something which is a good submission, really good submission. So that's really wonderful, and I encourage you to keep up the good work, particularly if you're in that top 10 points of part 1. You can see we have a number of submissions that got 0 in part 1. That's more or less because they didn't submit it so far. So part 1 and part 2 are completely different in these assignments. Part 1 is about looking at the specifications and doing everything right. And I look at it this way. Part 1 is the first 50 marks of the assignment. And part 2 is the second 50 marks. In some ways, maybe part 1 is the first 40 marks, and then the last 10 marks are hard to get. Part 2 is the first 10 marks. The first 10 marks of that are more easy to get, and the latter 40 are really hard to get. So the distributions for part 1 and part 2 look completely different. Basically, in part 1, we get this kind of normal distribution. You know, most people are getting something in the realm of 35 to 45. In part 2, we tend to get a distribution which can only be described as uniform, right? The whole class is spread across the 50 marks, and more or less there could be an equal number of people in each band of grade. I should say that I'm really, really impressed and happy that there are so many people who got full marks for part 2. Getting full marks in part 2 is really, really hard to do. Okay? It's really hard. It requires doing something which is not only exceptionally interesting and cool, but putting a design document together which is just absolutely clear and beautifully written to explain what you've done, how you've done it, and why. Now, what is not so great here is that there are a lot of people who got 0 in part 2. And this is not only explained by the people who didn't submit the assignment. There are a lot of people who wrote a part 2 submission, which I suppose was looking at one of the simplest problems in our list of suggestions. And if you do one of the very simplest problems for our list of suggestions, really you can't expect to get a mark which is very high. Nevertheless, it's certainly possible to get a good mark by doing one of the simple suggestions if you have a great design document. And what we saw with part 2 was that there are a lot of design documents which weren't great and in fact had no place being submitted as a university assignment. So people who have submitted those part 2s, if you've gotten 0 for part 2, I need you to have a look at your design document and understand why we don't consider it to be acceptable. And this could be because you were writing about something completely different, you were describing what happens in your wave and not what you've done in your program. It could be that you've just written very little text and it's hard to understand from the text exactly what you're doing. So when we're evaluating these assignments, we need you to be very clear about what it is you actually have done in your submission for part 2 before we can give you any grade at all. And really in part 2, the attitude which we have as markers is that we open your design document and we start looking at why we should give you marks. It's not like we're taking away marks for doing things wrong, it's that we're giving you marks for doing things good. And if you haven't done things in your design document which are acceptable at university level for a piece of technical writing, then unfortunately we don't award you any marks. So this isn't to say that this assignment has been a waste for anybody. I think this assignment should be a step in the road for everybody who has room for improvement in this course, and that's absolutely the majority of you. Most people have some way that they could be improving their assignment outcomes in this course. There's very few people, as I said, who got 100% in this assignment. In fact, I'll just show you that the overall total distribution. You can see that there's people who got between 90 and 100 were less than 30, less than 10% of our cohort were in that category. So most people have some room for improvement. And in particular, I'm looking at this group here who got between 40 and 50 total in this assignment. I think everybody in that column can move up to the pass band with a few targeted and precise changes to how you approach your design document, basically, and how you approach handing in assignments. So I'm getting a lot of emails and seeing a lot of messages on Piazza at the moment. Unfortunately, people are not satisfied with their marks, and we're processing those one by one. But basically, if you're not satisfied with your mark and you're in this category, unfortunately, the answer is that you're in that category because that was the quality of work you submitted. And I need you to improve that to take yourself into the 50 and plus ranges, okay? This is something which is very much doable for everybody in this course. Very, very much doable. Now I want to talk about what happens next, because As I said, this is formative assessment. You need to be looking at your feedback, taking these on board, and going on to the next thing. And the next thing is this. Assignment 2 has now been released. We should have our link available on GitLab soon, probably by the end of today. That link will be changed, and we'll put a due date in here. I think the due date here will be the very start of week 9, so that you have 2 weekends to look at this assignment. This assignment is worth more than assignment 1. It's worth 17 marks, not 15 marks. So this means that you get a chance to earn more marks for the efforts that you put in on this assignment. And now that you've done an assignment, part 1 and part 2 style for COMP2300, it should make a lot more sense about how to do this, and you can get started with it more quickly. So the idea with assignment 2 is that rather than creating just a waveform that makes one sound continually, you're creating a sequencer which can play back a whole song. Now, again, there's 2 parts. Part 1 is sort of a coding challenge. You just have to get some code to a very tight spec to work exactly the way we want you to. And in part 2, you do something a little bit more creative and open-ended, and then write a design document. So for part 1, we have asked you to program your disco board to play a specific sequence of notes. And we actually give you 3 options. So there's 2 parts of this Daft Punk song Around the World. I'm not going to play it back, otherwise I'll get a content mark on YouTube about it. We've also got an option to do the famous riff from Deep Purple. You know, it goes dun 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 dun. And we actually give you exactly what you need to know to do these, which is a list of frequencies and durations for each note. So what you have to do here is somehow get this information into your disco board and get a synthesizer algorithm to play back these frequencies and then stop playing them back for the pauses. This is sort of about 2 aspects of music that are really important. One is duration and rhythm, and the other one is pitch or frequency. So the duration or rhythm part is how long each sound goes for. And you have to remember that a really important part of rhythm in music is not only when notes are playing, but when notes are not playing. So the silence is almost as important as the sound sometimes. And then you need to be able to control your synthesizer to play different pitches. So whereas in assignment 1, you only had to get it to play 1 pitch, 440 Hertz, in assignment 2, you have to design some way that your synthesizer can play any pitch. Now, you get actually the listing for each song, and we've said here that for part 1, you have to play the notes with correct pitches. You have to play the notes with the correct tempo or timing, have those durations correct. As always, your code structure, readability, and modularity have to be impeccable for part 1. Absolutely the highest standards. That includes please put in comments and use functions. Make sure everything is just absolutely the highest standard. And we also have this requirement, which is that your sequencer needs to be, in some sense, modular, so that it would be easy to change what sequence or song you're playing. So that means that your sequencer could potentially be used for a different song if that was put into place. Now I'm asking this one extra thing. Much like in the first assignment, we had this challenge. If you want to get full marks, you have to do averaging over multiple periods to get 440 Hertz. In this assignment, to get full marks in part 1, you need to use some kind of data structure, for example, an array, to store your song's data and get it back. And the great reason to do that, of course, is that if you then wanted to have a different song, you could put that song's data in the array instead, and it would play that back just as the first one. Now there's some questions about frequency accuracy in this assignment. I do encourage you to read the whole of the FAQ and make sure that you understand all those points, and we can certainly discuss it on Piazza afterwards. Now we're up to part 2 for assignment 2. So in part 2, what I challenge you to do is to make a more advanced sequencer. So you have to add some kind of extra feature to the kind of sequencer you made in part 1 to enable it to do something that's even more cool. Now, the idea here is that your program at the end of this must generate some musical signal which plays indefinitely. You can either loop a finite sequence, or you might come up with some stream of new notes. Actually, the sequence that you play back doesn't matter. We want it to be a sequence which shows off the cool features of your sequencer. But if you want, you may extend the sequences which we gave you in part 1. You could add some information to them. I mean, not extend them in length, but extend them in terms of adding more advanced sequencing features. Now, I have to really focus on this point about what it is that makes a sequencer more advanced. So you have to keep in mind here that your job here is to make a cool sequencer, not a cool synth and not a cool song, okay? Even though you may want to use a cool song and a cool synth to show it off, we're grading you on the sequencer. So as written above, your sequencer, a sequencer is all about executing a scheduled musical pattern. So you need to create some program that can schedule execution of a more complex or multiple musical patterns, or do so with more utility or more features than the very simple sequencer you created in part 1. So keep this in mind when you're writing your design document. You need to tell us what it is about your part 2 sequencer which is more advanced, executes more complex or multiple musical patterns, or does so with more features. So that needs to be right front and center, top of your design document. What is it you've done and why is it more advanced? Okay? Here's a few ideas about what you could do. One idea is you could add some more aspects of music, not just pitch and duration. You could maybe add volume or dynamics, loudness, softness, as an extra sequenced item. You could add some kind of timbre or the type of waveform as a sequenced object as well. So that could be changing on a note-by-note basis. I see someone's asked in the chat about how we could play songs in part 2, but I'll just talk a little bit more about that in a second. A few more complicated ideas would be creating a sequencer that plays songs that are stored in a different format. It's maybe a subset of MIDI bytes or ASCII text. Another option could be to create a sequencer that can play multiple notes simultaneously. So it could be, you could be taking 2 of the songs from part 1 and playing them together in order to create a polyphonic sequencer and play the whole harmony of that Daft Punk song. Some other cool things is you could have amplitude envelopes, so changing the shape of your notes over time. That could be a sequenced parameter. And you could do something even like a polyphonic drum machine that sequences non-pitched percussive sounds with envelopes and synthesis parameters. This one's pretty tough because you would have to do a lot of work to get the different drum sounds. That means making a lot of different synthesizers that can create all the different sounds in a drum set. And then you have to make a sequencer which still has advanced features. So it can't just be about the drum synth. As always, part 2 is graded on your design document, the what, how, and why of what you've done. So be really careful about that. And I've even got an attention box to make sure that you understand how this is important. Someone has asked about how to find the notes for a song in part 2. Well, in a sense, that's up to you. But we do have a part 2 FAQ which has some handy hints. Whoop. it's kind of up to you to figure out what sequence you play in part 2. There's some instructions here on how you might go about finding the notes for it. I would suggest you have a look online to find either a PDF of some sheet music. If you don't understand sheet music, you could get a MIDI file. A lot of songs have MIDI files available that people have transcribed in order to, or written down the notes from the listening to the song in order to play it back on piano or other instruments. And then you could use this little widget we've got that converts between MIDI note numbers and frequencies. So I know that MIDI note number 60 is middle C, and that gives me the frequency for middle C. I know that this is D, that gives me the frequency. E, F, G, A, B, C. So I've been doing this for a long time, and I happen to have the MIDI note numbers memorized. I don't know why. Yeah, so this has just been released today. Today is the first day that I really expect you to be having a look at this assignment. So get through the document, make sure that you understand all these parts, look through the FAQ, and get back to us if there's any confusions on Piazza. Someone else on the chat has also asked if there's any way to get more feedback on the assignment, if you find your feedback is not enough. Of course there is. The best way to do that is to leave a private message on Piazza with your UID, and then the tutors who graded your assignment will open a discussion with you about the feedback and give you some pointers. Now, I should note that we do have a few extra pages on the website that are here to help you to understand how to do great assignment submissions. One of these is this page called Writing a Design Document. As you might guess, this is all about tips for writing a great design document. Actually, we have a plan to revise this with some new lessons for how of what we're feeling about how design documents are going. So you can expect some updates with this page, but you can find it on the resources page on the website. Down here, as where you'll also find the marking statistics. Okay. Now that we've gotten through the administrative stuff, we might get back to the actual topic for today, data structures. So I'm just going to take a break. Maybe if anyone has any questions, you could pop it in the chat and we might get back to you. I'm just going to take a sip of water before starting that. Seem to be a little bit behind on the old stream today. Waiting for everyone to catch up. Okay. Yeah, okay, so that's so there's a bit of discussion about how to get the music list of frequency. So the two methods I would suggest, looking for PDF sheet music of the song. If you can read music, this works. Otherwise, have a look at getting a MIDI file. You can view in lots of types of software. Oops, I posted in the wrong thing. Yeah, it's a little bit tricky to find the frequencies for a particular song you'd like. That's why we're open about what kind of song you could do in part 2. you could actually just demonstrate your sequencer by maybe constructing a sequence that demonstrates all its features, and that would be completely fine. But if you want to play back a certain song, then it's obviously a little bit of extra work to go and track down some representation of that song, either in MIDI format, sheet music, or whatever, and turn it into a kind of information that your disco board can handle. Okay, topic for the day, data structures. So I guess the question so far is why do we need these? Don't we have everything we already need in our disco boards? We've already got registers that can store data. We've got memories that can store data. We've got a stack, which is a cool thing. We can store data on that. So why do we need any more structures? Well, the answer really is that when we're dealing with more complicated programs where we're storing a lot of data, it often has some sort of structure built into it. So if we're thinking about a list of notes from a song, that's a list of something quite uniform. Like each note has a frequency, which is a number, and it might have a duration, that's another number. So each note perhaps could be described by a number of, or a couple of different bits of information put together that make some kind of record. And then the sequence of every note is some kind of list, or as we often say in computing, an array. So when we have these data structures available, we can deal with data in a consistent way and store more of it and access it more conveniently than we could if we didn't have these structured ways. If we didn't have a useful data structure, for instance, for storing a list of data, we'd have to sort of remember the memory address of each one. Whereas I'll show you that when we are using an array, we don't have to do that. We get to take shortcuts in terms of exploiting the fact that the data is regular, predictable, structured, in order to write an algorithm which can look at it much more easily than we could otherwise. Now, I guess one question is that one answer to this is that you want to be able to take your stuff with you wherever you go. So when you're a programmer, your stuff is the data that you need to operate on in your program, and you need to be able to put this in some kind of container to take it. And obviously we all carry a bag around when we're at uni. Probably our bags haven't had much use these days if we're stuck in the house. But still, the reason to have our bag is that we can keep all the stuff we need for the day in it, and that's just the same as our memory in our disco board. We keep all of our stuff that we're interested in operating on in it. But usually in a bag, you've got all the stuff you need, but you've got a certain place that you like to put everything. Like there'll be some slot for your laptop and a little pocket where you put your notebook or your phone charger or something, and maybe a little thing on the outside that usually has some headphones and a little ring to put your water bottle in. So everything's got its place in your bag, because it's good to be able to find things predictably. And it's similar with our data structures, that we want to be able to have a predictable way of getting data in and out of our program, getting it in and out of memory in order to have our algorithms work on it in some way. So here's a few answers. Why do we need data structures? To structure our data. Okay, that's a bit circular, isn't it? I guess the concept of data is that it only works in a structure if it's already structured, right? It has some kind of inherent structure which we can exploit. So if we copy that structure somehow into our computer, then we can use the structure to access it more easily. Another good reason is to minimize bookkeeping. So as I said before, we don't need to remember the memory address of every single note in our sequencer. We can have a data structure which kind of takes care of how it all gets put together. We certainly like data structures to make our lives easier. So imagine if you were back in COMP2300 and you had to do all of your work without arrays. It would be quite difficult to do much work in a computer if you didn't have this basic array data structure sort of sequence of elements that is predictable about how it works. So it certainly does make our lives easier. It means that our programs don't have to be as long, because if you had to remember every element in the array separately or have that as a local variable, your program would be super long having to define them all individually. And it's also great to play nicely with others. If we have these standard ways of doing data structures, then if someone else looks at your program, they could reuse it. They might be able to take your sequencer, change a few lines, or point it to a different part of memory, and it would play a completely different song without having to change the whole program. So the first data structure we're going to talk about, and this is the topic for the rest of today, is arrays. I've kept saying array, array, array all the time, but the concept of an array is an important one. I think I've got a big picture on the next slide, so I'm going to skip to that. Here's the big picture of an array. An array is some kind of collection of homogeneous data. Homogeneous means that the data is all the same in some way, or it's comparable. And the collection means that they've all been put together. So the big picture of an array is that we've got a bunch of elements which are all the same kind of thing. They could be an integer, they could be a word, they could be a string of a certain length, they could be a note, they could be a color, right? But they're all the same kind of thing and have the same kind of representation. And thus our array can have a sequence of them all in some kind of order. And if you want, you can have a look at Wikipedia about these topics. It's funny just to suggest going to Wikipedia, but Wikipedia is actually a fairly good resource for many of the topics in COMP2300. There's a lot of people have been kind of very carefully curating this kind of computer architecture, computer organization content on Wikipedia. So it's always good to have a look on Wikipedia and see what people are saying. So a few instances of times where we could use an array is if you've got a bunch of data where each element is the same type of thing and you want to access it all in a convenient way. We've already done this in this course, actually. We've already done it once with the shouty string demo, where I took a string using the ASCII's directive in memory, and I went through each element of that string and got back to it. Or extracted it from the string and changed it, put it back in there. So that was just an array of bytes, where each byte represented one character. You could also use an array for something like an audio file. Maybe you have a string of 16-bit signed values that are ready to go to your BSP audio out function that sends that value to the analog digital converter, or digital analog converter, sorry, that will change that value into sound. So a WAV file is an example of something where a whole bunch of values that are ready to go to the output of a sound device, such as you have on your disco board, are just all bunched up in memory. They're all ready to be played out. You just have to roll through them all, send them all to the DAC at the correct time, and you'll get your sound. Another example is maybe a collection of RGB integers that actually could represent an image. So an array could be, you could have an array that's just kind of left to right, left to right, left to right, left to right, scanning down each line of an image, and that is how we kind of store bitmap values in very simple images. So those are real situations where arrays are built into how we understand files on a computer or data storage formats. Strings, they're just arrays of bytes. Sound files, they're just arrays of samples. And images, basic bitmap images, are just arrays of colors. And the thing to keep in mind, or what's common between these examples, is that in each case, the elements are the same for each